My name is Bill Doherty, National Sales Manager, and we also have Mark Mays, his Senior Application Engineer Specialist, that will be presenting more on UL listings and Mojave. So one of the great things about Mojave is that it is actually, the inverter is designed and assembled in Washington State. The battery was designed in Reading, Pennsylvania by EnerSys, who owns OutBack. And that battery is going to be manufactured in Spokane, Washington. So it's a US assembled product, which is great. EnerSys, for those of you that don't know, is one of the largest battery manufacturers in the world, publicly traded, $3 billion a year revenue company. So EnerSys is backing us with this battery. And recently, the James Webb Telescope, the space telescope that NASA launched, has EnerSys battery, lithium batteries on that space telescope. So if NASA selected EnerSys and our lithium, I think you can be confident for your home and your customers' homes. So just to let you know as well, the AC coupled version of Mojave with the ESS battery, that's actually going to be shipping out in May. We've already kind of sold through the first round of orders, which is good. And then the DC coupled version of Mojave will be available in Q4. And you should be able to buy just the AC coupled Mojave inverter or the battery come May individually. So really exciting time here at OutBack. I'm going to hand it off to Mark Mays, and he can get more into the technical side. So take her away, Mr. Mays.
Okay, thanks, Bill. So let's go ahead and start the beginning here. Thank you, Andrea and altE, for this opportunity. This is, I think, my 7th year in a row of participating in the conference. It's one of my favorite conferences. I kind of miss the real face-to-face contact with everybody, but I'm sure that's going to happen again someday. But also, for those of you that are wanting to get NABCEP credits, I just need to go over a couple of things with you. One is adding storage to an existing solar energy system is how we register the course. There's a different title that we used in the altE conference program, but this is the title that you'll need to, when you look up the course, adding storage to an existing solar energy system is the course name that you look for. And we did register for a 2-hour course. We're doing a 1-hour version here at the conference. So you can only claim one, okay? So I just wanted to get that out of the way. Okay, so let's go ahead and take a look at today's agenda. We are going to talk about UL 9540 energy storage systems, what it is. There's been some changes to UL 9540. There's a second edition out, so we'll talk about some of those things. UL 9540A. We're also going to talk about AC versus DC coupled inverters, energy storage options from OutBack, and just go over, how you would go about commissioning a UL 9540 ESS using our new Mojave inverter as an example. Okay, so we're going to start talking about what is UL 9540 ESS. Okay, this standard first came out in 2016. It's to give peace of mind for energy storage customers. I remember back in the day when I started with OutBack 11 years ago, we get calls from installers. They got a pallet full of parts and some batteries, and they're doing a field integration of the system, and that kind of. And some were definitely better at it than others. I some pictures of some really good installs and some that were just really troubling. And then that kind of evolved into pre-wired systems, which, the integration we'd be done here at OutBack, and then, shipped to the field. And then there was still a lot of, programming and setup that needed to be done. And so there's been this sort of evolution. And now, all the regulatory agencies, for example, the International Residential Code, which has been adopted by 49 of the 50 states, are requiring UL 9540 for an energy storage system. So it's a standard that says, okay, this is what it has to be. No more, kind of rolling your own system and kind of putting together a system. And the whole goal is to eliminate these poorly integrated systems that are unsafe or they underperform. They don't perform as promised. One nice thing about having a UL 9540 system is, that UL stamp should expedite any permitting that you have to do from your local planning board or your local jurisdiction. And so these steps we've been taking along I've been trying to stay on top of UL 9540 to demonstrate our commitment to safety and performance, because it's really important that customers are happy with the way it's performing, and that it's a safe system, that it's going to be, when it's set up, it's going to perform properly, it's configured properly, it was designed properly, and installed properly. So from a regulatory standpoint, a UL 9540 energy storage system is comprised of a UL 1973 certified stationary battery pack. A lot of batteries, especially the AGM batteries, were listed under a different UL, like 1778 or 1989, but it is a UL 1973 and a UL 1741 certified inverter. Okay, so there's a lot of testing does, thermal testing, electrical testing, crush proof testing, and we'll just jump to this next slide here. The UL 1973 requires battery safety listings where, a lot of testing is done, including this crush test you can see in this little graphic here on the bottom right. And it's looking for, short circuit, crash, fire, puncture, outgassing, flammable gases, that sort of thing. So it is required to obtain a UL 9540 listing. So UL 9540, you can get that mark from a nationally recognized testing lab. That could be UL, could be CSA, the Canadian equivalent, could be Intertech. There are others, but it has to be a nationally recognized testing lab, and they can mark it as a DC ESS, so UL 9540 DC ESS. So that's the situation with like battery manufacturers or people that only offer batteries. When the standard first came out, it was like, hey, wait a minute, you're saying I have to sell an inverter with my batteries. So that was a little bit, people that make these regulations, they don't always see, the marketing business side of things. So the DC ESS mark says that this battery will be paired with most UL 1741 listed inverters. So the battery manufacturer that gets their batteries with a UL 9540 DC ESS mark will also provide a list of UL 1741 inverters that should work with it. An AC ESS, it's a mark on the shared enclosure. That is primarily with like the Tesla, and I think Solar Edge and Enphase have these high voltage batteries, and they're calling that an AC ESS. A multi-part ESS, so that would be like a Mojave. So our inverter and the battery together. So that mark could be the UL 9540, could be on the battery, could be on the inverter. Okay. So again, the requisites include a UL 1973 battery, listed battery, or a UL 1741 inverter. Okay. And these listings, the UL 9540 listing, in addition to IRC, it's also required by NEC and most stationary energy storage system products. So you're pretty much going to have this if you're getting your job permitted and inspected. This will be a requirement. So UL 9548. So it's a test method. There's no pass-fail criteria. There's no marker listing. Okay, so it's not a listing with a mark on it that says UL 9540A. Okay, it's a written report that will probably require some professional interpretation by, local planning board or system designer. And so it corresponds with what's required by the IFC and NFPA. And the data is going to be used by the local authority having jurisdiction to determine any site-specific requirements for fire suppression and any other hazard mitigation systems, like if there's explosive gas that can be emitted when there's thermal runaway. So it's not saying that there will be fire suppression or other hazard mitigation systems required, but they will look at the data of the test. Like, for example, part of the test that they do for lithium batteries is they wrap the cells in a thermal blanket that will heat up and force a thermal runaway condition. And then they look at adjacent cells and see if that thermal runaway propagated to adjacent cells. That's one test that they do. They also test and see if any flammable gases are emitted during this forced thermal runaway test. So there's these kinds of things that happen. And so they look at that test result and say, oh yeah, there's the thermal runaway did not propagate to adjacent cells or just a couple. There's no gas being emitted, then it's probably not going to require anything. They'll probably just say, okay, we can go ahead and go forward. And the reason that's really UL 9540A came about is because with UL 9540 second edition, there's now a requirement that says the maximum you can put in a residential home is 20 kWh battery bank or 50 kWh non-residential, and there has to be a minimum 3 foot space in between the batteries or battery racks. So now there can be an exception, but it's going to require this UL 9540 fire test report. Okay, and they're going to take that report, and as I said in the previous slide, the system designer, the code authority, they're going to review the report. They're going to determine, if it could be, that 20 kWh and 3 foot spacing can be exceeded. Like if you were to test, if the battery manufacturer were to test with a 50 kWh battery system, and they had them adjacent, like 1 foot apart, 1 inch against the wall, and that's how the test was conducted, and there was not propagation of thermal runaway, there was no explosive gases emitted, then they would probably allow it, but not without that test, okay, that test report. And then they're going to evaluate the flammable gas, and then if necessary, then the approval to make a bigger system might require a code mandated explosion control system or something to some fire suppression system or something like this. Okay, so any questions so far? Okay, you good, Bill? Andrea?
Yes, sir.
Okay.
Yes, thanks, Mark.
So lead acid AGM batteries, does UL 9540 apply? Well, technically yes, but let's take a closer look here and see what's going on. So I found this UL 9540 white paper from UL online, and in one of the paragraphs in there, one of the sentences there, it says the 2018 editions, which is the second edition of the IFC, IRC, and NFPA Fire Code, first introduced requirements aimed specifically at modern energy storage system applications with a focus on lithium-ion battery installations. And I'm sure that was due to a lot of highly publicized cases with, people's laptops catching on fire, phones overheating and catching on fire, the Boeing Dreamliner, when initially its lithium batteries caught on fire, and they wound up, encasing it in a fireproof metal case. There have been EV fires. There's been some energy storage system fires too, I believe. I won't mention names, but I know that there's been some out there. Okay, so anyway, the focus was on lithium batteries, and reading further on in that white paper, it says that energy storage systems using lead acid or NiCad batteries that are within the scope of BL 1778, which is a standard for uninterruptible power supply equipment, and only serve as a UPS, are outside the scope of UL 9540. Okay, so this is like a lot of telecommunication sites. They'll run on 48 volts, right? And they've been doing this for like since the telephone was invented, basically. Telephone equipment's run on 48 volts, and you know the old landlines, you could lose power, and you could pick up the receiver on your telephone and get a ringtone, right? Because it all comes all the way back from that telecom front end office there, where they have this huge bank of 40-volt batteries. So they've been around for a long time. They've been used a long time, and so there's an exception for what they call a communication utility, is how that's described. So it could be Comcast or AT&T cell tower, or Comcast pet-in, whatever. So anyway, where does that leave us? So OutBack Energy Cell AGM batteries from NSS, we're listed to UL 1989 for standby batteries. And so these batteries by our parent company Alpha Technologies, which in turn got bought by Enersys, they do provide converter systems, like they change AC to DC for to charge the batteries, these huge battery banks that they have. And again, these AGM batteries have been used forever. AGM batteries I've seen from many different battery manufacturers out there have been installed forever, since I've seen it in our industry for energy storage systems. But now UL 9540, it does apply, and it does include AGM batteries, but these comments up here highlighted in yellow does tend to make one think that maybe there's some gray area here, because we've always told people, well, it's a UPS battery, then maybe it could be approved by the local planning board depending on their interpretation of this. Is it an exception? Is it outside the scope of UL 9540? Technically, no, because it's UL 1989 and 1778. But it kind of depends on what code cycle they're on. Have they adopted code cycle that compels them to only approve UL 9540 energy storage system? And we think it's a good idea. People should have that, and we are going to have at some point some UL 1973 AGM batteries, but we don't as of yet. So again, the bottom line here is approval is totally up to the local authority having jurisdiction. Your HJ is going to have the final say so. The planning board that issues your permit, those are the people that are going to say whether you can still use an AGM battery or not. They may require UL 1973 or a UL 9540 DC ESS listing. Any questions? Yeah, looks like there might be some in the chat.
I assume that if the batteries are located in an outbuilding, the maximum capacitor requirements go away.
I don't believe that's the case, because it's an energy storage system serving a house. I would, it's not really for me to say, because now you're getting into like all these code interpretations, and I would say, talk to the planning board that's going to approve your permit, talk to the inspector that's going to inspect it, talk to these local authorities having jurisdiction where you're going to do it, ask them. But for sure, UL 9540 is going to be accepted. And if there's a, like when we're going to be able to add stack batteries on our system. And when we do that, we will have a UL 9540A test report done. And we're pretty sure it's going to look very good. And there shouldn't be an issue adding more batteries. They just want to make sure that this additional testing is done that, you know, when they force a thermal runaway condition, that it doesn't spread and it doesn't catch on fire and it doesn't emit explosive gases. It's all for the protection of the consumer. So, but yeah, it's you know, check with your local authority. They're the ones that are going to tell you whether that's allowed or not.
Mark, does 9540 apply to lithium iron phosphate batteries?
Applies to all batteries. If we go back up here, somewhere, all chemical batteries, basically every battery, AGM, lithium, every form of lithium. There's no getting around it. Yeah, there's no every battery out there. Okay.
Good to go.
Okay. So AC versus DC coupled systems. Okay, let's talk about that a little bit. So when we talk about AC versus DC coupling, we're talking about how do we get the PV energy to the storage system. Okay, so pretty much all storage systems these days are DC based. Now some of these AC ESSs, high voltage battery systems, the battery is inaccessible to the user, so it just appears that it's AC in, AC out. But there is a battery inside. Okay, so when we say DC coupling, we say how does the PV get to the storage? So in this case, we have the DC to DC converter. It takes the irregular voltages off the array, converts them to DC voltage. When the batteries are full, that DC energy will continue to flow off to the inverter. The inverter will convert the DC into AC, provides power for the protected loads panel because we typically separate loads off from the main panel to a protected load panel because otherwise we need way too much battery to typically run a whole house for at least 24 hours. So people say, okay, I'm just going to get my critical loads, protect them, and have them back up. If there's still energy left over from the PV being generated, then that will go to the main service panel. There's still energy left over, and you have a net metering agreement, you can send that power out to the grid. Okay, so DC coupling is how we get the energy to the storage system, the battery. Okay, so the starting point for AC coupling is this grid-dependent inverter. A grid-dependent inverter, they're like 90% of the solar installations, residential solar installations, are with grid-dependent inverters. They don't have storage. They're basically using the grid like a battery, if you will. They self-consume. They convert the DC to AC. They consume whatever's being produced, and then they send the rest out to the grid. And then, when the sun goes down, then they get their energy back. So it's kind of like treating the grid like a battery, if you will. Problem is when the inverter needs the grid to operate, it needs to synchronize to that grid voltage and frequency. And if that goes away, then there's no energy available. A lot of customers that buy these grid-dependent systems are not always aware that when the power goes out, their solar is basically useless. Okay, so when we do AC coupling system, we take some of those loads that are critical, we move them to a protected load center, then we insert the inverter in series here. So this is just a power flow diagram. These aren't actually hooked in series. The output of this inverter, the output of our inverter, and this load panel are connected in parallel, even though the power flow looks like it's in series. So we call this AC coupling because the PV energy is converted to AC, and that renewable energy comes to the battery on the AC side through our AC output and then through our H-bridge inverter circuit into the battery for storage. So it's being coupled via AC, not DC. The DC is this part up here. Okay, so when the grid is running, we basically act, our function is a copper wire. We're just passing through the energy from the array through the grid inverter for some self-consumption on that protected load panel, fill up the battery if it needs it, more self-consumption out here on the main load panel, and if there's anything left over, it goes on out to the grid. Okay, then, excuse me, at the end of the solar day, sun goes down, then it comes back the other direction. So again, we're still in a pass-through mode, you know, acting like a piece of copper wire. In pass-through mode, we're passing energy, you know, through to the protected load panel. Okay, then the next day the cycle starts over again. So back and forth. Okay, there's another thing we can do with Mojave that's pretty cool. We have this external CTs on here, and what we do is there's a couple of use cases here. One is in places where there's multi-tiered rate structure, like California, Hawaii, and I believe Massachusetts and New York also have multi-tiered rate structures. If you want to self-consume some of your stored energy here, while the rates are high, what we can do is we can go into what's called a time use period. So we set the time that we want to self-consume, and we can take energy from the array if it's happening, that self-consumption period is happening during the solar day, and blend it with energy from the battery if necessary. And here is what we call a grid zero point. So we're not exporting to the grid, and we're not importing from the grid. So we send just enough energy to power these main panel loads, and we zero the grid at this point. So if we see there's energy starting to be exported, then we reduce the power going to the main panel. If we see that we're starting to import, then we'll increase power going to the panel. So we use this external CT to maintain that 0 point. So when we have a power outage, now our inverter becomes a heartbeat, if you will, that the grid-dependent inverter can synchronize to. And that will allow it to keep producing PV during the solar day, power the backup load panel. If the panel needs more energy than what's available from the PV array, then we'll bring in some power from our battery and we'll blend it in with the renewable energy. Then if the energy is more than what's needed during the day, then we can use that to charge our batteries. Okay, so basically works very similar to being grid tied, except we've become the new grid, if you will. And then at the end of the solar day, it's just used like an off-grid emergency backup power application. So we're powering the loads at night until the next solar day.
Hey, Mark, sorry, I actually have a question here.
Okay.
For the main panel, if we did add an automatic transfer switch to the main, would we be able to still power up the main loads?
We would not, because there's no grid signal for us to sync to. So if there's no grid power here on the AC input, then we have to by our UL listing, we have to maintain that as an open circuit. We can't back to the grid. The only exception might be if you had an auto transfer switch out here, and a grid, and you had like a generator connected up. So if you lose grid power and it switches over to the generator starts, then that comes in, then yes, then we would pass that generator power to the loads, and then we could also use that generator power to charge the batteries if we chose to. So that's the only case, because in that case, then we do sense that there's AC input, but if there's no AC input here, we can't backfeed.
Yep. And because in the grid zero example, there's still the ability to backfeed the grid. That's why it can't happen under grid zero.
Yeah, because if there's no grid here, we have to open the circuit. It's our listing requires that.
Gotcha. Thank you.
Okay, so comparing, excuse me, our Flex Power Radian, which is a DC coupled system. Now we can AC couple with it, but Mojave does such a good job with AC coupling. There would be no reason to buy a Radian to do AC coupling. Now Mojave will have a DC coupled version of this by the end of the year. And but for now, in terms of DC coupling, it would be our Radian inverter with the 2 solar chargers that do the DC to DC conversion, do the DC coupling to the battery. And that comes in we have like 2 4 kW kVA power modules inside. So you can get one that only has 1 power module and one with 2, so either 4 kVA. Mojave is only an 8 kVA system. Radian is probably the best inverter out there at doing surge. Nobody has a 16 kVA spec that I know of on a 8 kVA inverter. The Mojave has a 10 kVA. I put a little plus sign after here because we do things a little bit differently with Mojave. We maintain the maximum current output. That 10 kW is 48 amps AC. And so when we have like a surge device, we'll just make sure that 48 amps AC is there all the time. It doesn't go away. And we will allow the voltage to collapse while that's happening, which shouldn't be a problem for most surge loads. Most surge loads are current devices. They just need the current. And so we maintain that current. And I've done the surge testing I've done so far. So far, all the big heavy surge loads that we've done testing with Radian test out just fine with Mojave as well. So that's why I kind of gave that 10 kVA plus. Don't think in most cases you're going to have a problem with Mojave. Okay, in terms of time of use, it's kind of basic with Radian, although in a DC coupled application, we can put grid use timers and we can schedule time to go off grid, and it works pretty well if you wanted to go off grid during a high rate period. Mojave is definitely more advanced in this time use functionality. And one of the things that it can do, which is pretty cool, is you can disable grid charging. So if you're AC coupled time of use, the Radian couldn't really handle that application very well. We could never guarantee that it wouldn't charge from the grid. With Mojave, we can say, okay, we're only going, if we turn off, grid charging, we will only accept power from the AC input to the battery. And that's new. The other thing we can do that the Radian and what I've seen from other inverters, when there's very little power demand, in an off-grid situation, AC coupled, and so the batteries are full, very little power, it comes back to an unregulated charge, and we have to try and curtail that grid-dependent inverter. With Mojave, we'll do the same thing, but to protect the batteries, we just open up that pathway. So the batteries are always going to be protected.
Hey Mark, do have one question here, kind of on the topic. Could we avoid a backup load panel, just back up the main panel, if we included an ATS between the main and the utility?
You can, what some people have done is they'll put like the output, like say in a DC coupled scenario, you can take the output of the inverter and put it to the generator input on that panel. But yeah, you're still going to still going to be a little bit tricky. I haven't really thought about it in an AC couple situation, if Mojave would be able to do that. But I know with Radian, we've done that in some cases, for a whole house backup. They're driving connecting a generator. We connect the output of the inverter to the generator and put on the ATS. And in those cases, we can. So I would say for now, contact me afterwards and let's talk about your application and we'll need a lot of solution. I'm sure we can figure something out that'll work. So whole house backup, a lot of people want to do it for good reason. They don't want to have to pick and choose what loads to back up, and it is feasible. So under self-consumption, we have whole house, but that's not off-grid. So that's when you're grid connected, but we want self-consumed. So it is a little bit different application. But it is doable. Might take, some relay logic or something to make it happen. Follow up with me later. Okay, integrated PV. We can have up to 7 kW of nameplate, solar panel nameplate for these guys. Realistically, you're not going to do more than 6 kW because they're 100 amp charge controllers. So it's 100 amps times whatever your battery charging voltage is. Most battery voltages, charging voltages are 57 volts or less, which would be 5,700 watts or less. Could be if you have a flooded battery with 63 volt equalization, and even then, I doubt if we would go much above 6,000 watts. I think that's where the actual number is. Okay, in terms of integrated PV, right now it's just AC coupled up to 8 kVA. Off-grid, that's kind of what OutBack is known for. Normally, I would say never do AC coupling on an off-grid situation because you're going to be cycling the batteries every day with poorly regulated DC charging. And I always tell people don't do it, especially with lithium batteries. AC coupling is not a good idea. With Mojave, I would say no problem. The Mojave regulates the DC voltage so well. I've been testing the Mojave since last August. I've really run through cases, the worst case scenarios like no load, full battery, and it does multi-level charging, so it'll do a complete full absorb cycle. It locks right in within a couple tenths of a volt, or it's not right on the money. It's really, really good. The best I've seen is like Radian and some kind of units like plus or minus half a volt. Sometimes on a non-SA unit, that's even worse. Okay, so choosing the right battery. So if you can use an AGM battery, this is kind of our current offering. These are UL 1989 listed. The pure lead battery has a long flow life. It's got a great operating temperature range. Cannot be overcharged from PV array. This is unique. Most of like lithium batteries and even a lot of AGM batteries, even our high capacity batteries, they need to have a maximum charging current that needs to be followed. With our PLR battery and our BLU, the blue battery over here, that's not a problem. They cannot be overcharged from PV array. So if you're going big on solar, small on battery, which a lot of people want to do, is hey, I just need to back up for a couple hours. I want a small battery bank. These batteries are great for that application. This also, because it's long flow life, you could discharge this down to 80%. You're going to give up a bunch of cycles, but 675 cycles, I mean, that's, probably, 4 weeks a year for 10 years at least. And that would mean that typically you could get by with 2 strings of batteries, where if you're going 50% depth of discharge, you would need 3. Okay, so that's something to keep in mind. This is a great emergency battery backup battery. The blue battery is more of a cycling battery. It has 20,000 or 2,050 cycles at 50% depth of discharge. That's a good off-grid battery because it has partial state of charge. It likes to live in that. It can be fast charging. And again, it can be overcharged from the array. Now we have our XLC high capacity battery. It's got a 17-year standby life, 10-year full replacement warranty as long as it's been monitored during that time. 3,800 cycles at 50% depth of discharge. That's like, lithium ion cycling ability. So that's a really nice, nice battery. Then we come to Mojave. It's a 15 kWh NMC lithium cycling battery. It's industrial grade, as Bill mentioned. These are used like in forklifts. They're used in aerospace, drones, and defense aircraft. The James Webb telescope they just launched. So these are definitely industrial grade batteries. And EnerSys, we've been making batteries for over 100 years. So we know how to design and manufacture them safely, so that they are safe. The DMS makes a plug and play with the Mojave inverter. Basically, just hook up the 2 battery cables, the ground wire, and a CAN bus cable, and that's it. It's the only connections you have to make. Talk about that commissioning in just a moment. And then, so the 12 kWh at 80%, which is our recommended depth of discharge, is 12 kWh. That's equivalent to 3 strings of AGM batteries, which is about 13 kWh. So you get a little bit more kWh with 3 strings, but they're basically, think of it as 3 strings of battery. But the other thing you have to keep in mind, that's really, if you're in a cycling application, at most, you're probably going to get 5 years of battery life out of it, and probably less. And you'll need to get another 3 strings. So you're really looking at 3 strings of battery over the 10-year life equivalent of Mojave. So if you do, then you'll need a battery rack for it. So by the time you add up all those costs, they're pretty comparable to a Mojave battery. Okay, so now we're going to talk about what options do you have for OutBack. So we have our Flex Power Radian. This is basically, and then this is basically our DC coupling option. And we have a UL 9540 DC ESS. That's this rack, but it was certified with Simplify batteries. It got that listing, so only Simplify batteries work with this battery rack. But this is like an example of a DC ESS. So this solution here, you can get the Simplify batteries through altE and everything else, altE from OutBack. That is our DCSS. Mojave is a UL 9540 ESS. So these are your 2 options from OutBack for UL 9540. Okay, so what does it take to put one of these in? You put up the wall bracket, mount the inverter. I think the quick start guide says to do the battery first, but really it's probably talking to people putting these in. It's really going to be easier to put the inverter in first, then move the battery into place because it is heavy. It's 465 pounds. So it is a heavy battery. So these are the connections I was telling you about from the battery into this BOS box. So the 2 4-out battery cables, the ground from the ground, and then the CAN bus cable comes into plugs up into here. Okay, and then how to move a heavy battery? Well, this is the right tool for the job. This is like a furniture hand truck. It's nice and tall with leverage. You've seen we got Jorge, our apps engineer. He's actually, this is the installation at his house of the battery. So you can see he's doing this all by himself. Now, probably would be advisable to have another person on site, however, to help with putting this into place. Right tool for the job. And then in terms of wiring, again, your DC connections go here, the neutral connection, your grid AC input goes L1 and L2 goes here and here. These are pre-wired from the inverter up above. If you add a generator, you get this breaker from us. It's a 6-amp breaker. It's just a bin mount, just clips right in. You will have to put the wires in up into the inverter though. You will have to take the inverter from cover off. to do that. Add a generator, then put your L1, L2, neutral and ground connections. The generator. Then to configure it, you go to click on the settings, select battery, click over here on the drop-down menu, and then pick a battery. Okay, so it's our battery, it's Mojave. I don't believe we're going to start selling the battery and the inverter separate until like later, what, May, June timeframe?
Right around there, yes.
So, but in the beginning, we're just selling them as ESS packages. So you come in, you select Mojave, but if you opted for a different battery system in the future and it's a whitelisted battery, you select it from a drop down and then all the battery settings done. So the main thing is you can do that if your battery's not on this list, then you do a custom lead acid or custom lithium and then put the settings in as you need. And one keep in mind.
Sorry, Mark. And by the way, we will be adding more kilovolt options to this drop-down list when we can get to the evaluation. So that's coming soon.
Okay, more kilovolt coming. So for now, only use the 1741 SA compliant grid dependent inverter with Mojave. The non-SA units, the ones that the upper end frequency is only 60.5, not 62 hertz. There's not a frequency range to control them. They do this what we call bang bang charging, and come on, surge up, shut off, turn off for 5 minutes, turn on, surge up. So unless there's lots of power to absorb all that energy, you can get into this what we call bang bang charging with it. It's just hard on the battery, and that's why I don't recommend doing AC coupling with an inverter. Normally with Mojave, even with a Mojave battery, we're saying that we need to have full regulation over that grid dependent inverter. We need to be able to curtail it when we need to. And so that is a requirement with Mojave, that your grid dependent inverter is SA component. Okay, so once you've got all your battery configured, just drop down. There's another drop down for the grid. So talk to your local utility and find out what standard they want you to be. The default is IEEE 1547/2018. I'm sure most people would be okay with that. The old standard where the grid dependent inverter drops off at 2003. That means that it's a non-SA compliant inverter and you would not do that. So I'd say IEEE 1547/2018 or California rules ones or the HECO ones. Those all support frequency watt where we can curtail the grid dependent inverter if we need to.
Hey, Mark, we did have a question here, and I have no idea why someone would want to do this, but somebody was asking, can the battery be used with Solarc 12 kW inverter?
Our battery?
Correct.
Not at this time. I don't, somehow somebody would have to figure out how to coordinate, our BMS with that inverter. So I'm not sure how that would work.
Isn't the question more CAN bus versus Modbus and the functionality of the Solarc inverter?
I just say the Solarc would have to have the firmware that would work with our BMS.
Yep. And see, this is one of the huge advantages to OutBack and our Mojave ESS, that is a complete system where it's one throat to choke, where it is our inverter, it is our battery that is designed by EnerSys, a $3 billion a year publicly traded company that is going to be there in the future to back up the warranty. So that's one of the huge advantages to a complete ESS and being backed by a company such as EnerSys. So that's my 2 cents.
Okay, thanks, Bill. So this is so after you've done the configuration, you come and you hit the status tab up here, and then you can look at status, inverter, battery, grid, and so on. Here we're showing the grid. We're showing the power flow diagram. Energy coming up from batteries green, those are green dots going to the load. is being blended with power from the grid. Those are the red dots. Notice that there's current coming in. We're using our external CT, so kind of a self-consumption thing going on here. So you got full power, frequency, voltage, and current on L1 and L2, external CT currents, time of use status. So it's all right there, very easy to use interface. So the interface is whatever device you choose that has a browser. So you just need a browser. You connect to our Wi-Fi. It's a super strong Wi-Fi. I can connect to it 150 feet away through 3 walls. So really strong Wi-Fi. So once you just put in your serial number as your password, and then once you have that in there, then it's just a matter of connecting that Wi-Fi and use your browser as the user interface. Okay.
Mark, I've got another question here, Mark. Sorry. Is there anything preventing your battery from running standalone with its BMS when connected to other systems, or does it require the communications connected to work?
I believe it requires the communications connected. I don't think you can operate it in kind of a dumb mode, if you will. That's what I'm guessing. That's a guess. I don't have a definitive answer for that. And we can get back to you on that. But again, this is something that we're still some months away from. But right now, they're a package system. So I just wanted to talk about service for real quick. So for right now, there's a problem with the battery. We are going to send somebody out there for the battery. Excuse me, the inverters are going to come off for the first few months. We're going to swap out inverters, and then because we want to evaluate if there are any problems with the inverter. We want to evaluate it. I've been using mine regularly since last August, and it's a pre-production model, and it works great. I don't have any problem whatsoever. But it is designed to be field serviceable. There's circuit boards that can be replaced inside. So after this initial 6-month period, we'll be able to replace boards on site. But for now, it's going to be an inverter swap and a battery swap for service. Okay, that's all we're at. I see we're like kind of 5 minutes to go to the next session. If you have more questions, please bring them to the networking session later, and we'll try and get those taken care of.